The universe is enormous, but how enormous is it for? For generations, people have looked at the stars who are unsure about the actual scale of the cosmos since the invention of telescopes. We have pushed the powerful Hubble to limits of what we now understand with the James Webb Space Telescope's debut. The veil is being removed from the unfathomable vastness of the universe. The James Webb Space Telescope was much praised as the Hubble Space Launch's replacement. The telescope heralds a new age in astronomy. Began operations on December 25, 2021. It is an engineering marvel of our time. Has a mirror that is more than 6.5 meters long and a 1.5 million kilometer orbit. The purpose of the Webb away from Earth is to peer more profoundly than ever. Prior to Hubble, which mostly looks in the visible and ultraviolet spectrum, infrared is the main topic of Spectrum Webb. Enables it to see through dust clouds and gas that reveals things that have never been previously noted. With this, the secrets are being revealed via the capabilities web of the beginnings of the cosmos and giving us a better understanding of its actual size. Since its inception, the James Webb Telescope has already sent return amazing pictures that defy fantasy from far-off galaxies to each picture offers areas where stars are developing. They are more than simply beautiful pictures. Information that enables us to comprehend the immensity of the cosmos and the web. What has been discovered so far is nothing less than its attention to the infrared is remarkable. Spectrum is not only a technical term accomplishment, it's revolutionary in the way we infrared light has the ability to comprehend the cosmos. Wavelengths that are longer than visible light, letting the web see through the cosmic dust clouds and reveal areas that have stayed out of sight. For instance, star-forming regions covered in thick gas and dust clouds are almost invisible. Having an infrared web but to visible light has the ability to peer through these clouds and capture the beginning of planetary systems and stars. These pictures provide us important information that aids in our comprehension of the procedures, can result in the creation of stars and, finally, the emergence of new solar systems. In one of its first findings, Webb showed a star-forming area called as the foundational elements of creation situated in the pictures taken in the Eagle Nebula. Infrared displays a certain amount of detail never previously seen, emphasizing the complex gas and dust structures that support the development of new stars. One among the most significant findings made by the James Webb Telescope has a connection with the universe's expansion. For scientists have known for decades that the cosmos is growing, yet the Webb's new insights are being gained from observations. By looking into this phenomenon, the network of distant galaxies is beneficial. The rate of expansion is measured by scientists with hitherto unheard-of precision. This has consequences on our comprehension of dark energy. Is the enigmatic force that propels the rapid growth of the dark energy is still one of the universe's largest cosmological riddles. It creates up around 68% of the cosmos, although we know very little of the info on its site is vital to the advancement of scientists. Fresh hypotheses and models that could describe the characteristics of dark energy and how it impacts the expansion of the cosmos. Observations of faraway supernova via the Webb, exploding stars that act as cosmic yardsticks, are very crucial. In this sense, by looking at the light, scientists may learn from these supernova, calculate the universe's rate of extension and improvement of their estimations of the impact of dark energy on the James Webb. Additionally, a telescope is providing light on the early universe. A time period referred to as the cosmic dawn is the time period that, around 200 million years after the major bang, signifies the beginning of the first. Studying galaxies and stars at this time is essential to comprehending how the the universe began as a hot, dense state, to the enormous, intricate cosmos that we see today. The infrared capabilities of the Webb enable it to gather illumination from some of the first ever created galaxies. These old galaxies are seen as bright patches of. Their luminosity is redshifted by billions of cosmic expansion years. By examining these galaxies can teach scientists on the circumstances of the cosmos and how the first structures created. One of the most important online findings is the identification of atypically massive, developed galaxies in the early. These galaxies emerged in the universe only a few hundred to 100 million years after the Big Bang Theory challenges about the speed at which galaxies may develop and change, which has raised new queries and fascinating potentialities about nature of the birth of galaxies. Whereas the James Webb, the scale of the telescope is becoming revealed. The universe aids in the hunt as well for life beyond the capacity of the Earth's network to examine the exoplanets' atmospheres. One important factor is planets circling other stars. This Quest Webb's tool can identify the chemical makeup of the exoplanet atmospheric conditions by examining the light that travels across them as the planet transits its star. Using a method called as transmission spectroscopy makes it possible for researchers to determine the existence of gases like carbon dioxide and water vapor. Even oxygen and methane have the ability to. Signs of life are among the most fascinating findings the Internet has produced is the water vapor detection in the atmosphere of an exoplanet in the distance, situated inside its livable zone. The area is known as the habitable zone, around a star where circumstances may be the existence of liquid water, which makes it's a great place to look for life when we're still looking for conclusive proof of extraterrestrial existence. The views from the Webb are giving us more intimately than ever by examining the exoplanet atmospheres and finding those who have the capacity to. We're taking the first steps in life in an effort to respond to the perennial query, are there any black holes in the cosmos except us? Are among the most enigmatic and intriguing cosmic things. In certain areas of space, gravity is so powerful that light cannot escape. Have long been the focus of research. The James Webb Telescope is currently a source of interest, giving us hitherto unheard-of perspectives of black holes and their surrounding areas. One of the major accomplishments of the Webb is catching the supernova's accretion disks. These disks were composed of enormous black holes, spiraling dust and gas into the dark. Hole release enormous quantities of energy. Studying these disks online is beneficial. Scientists are aware of how black holes develop and the ways in which they affect galaxies that envelop them. In addition to the Webb's observations are exposing the intricate interactions between black holes and their settings, such as the Webb high-energy particle jets expelled from black holes at about. These jets can go faster than light. Significant effect on the environment. Galaxies that control the production of stars and forming the cosmic environment as we keep exploring the cosmos with. We are also using the James Webb Telescope, acquiring fresh perspectives on the vast cosmic scale structure. The universe isn't just a collection of stars and galaxies. Instead, it is arranged in a huge cosmic network with clusters and galaxies joined by strands of the web of dark matter. Scientists are using observations to map more specific information on this cosmic web than before by looking at the distribution of the dark matter web's galaxies is offering fresh hints on how the structure of the cosmos developed and changed thousands of years ago. One of the biggest stunning findings on the Webb are the discovery of massive clusters of galaxies. It may be found in billions of. These clusters are light years distant. With thousands of galaxies, they are one of the largest buildings in the data from the cosmic web is beneficial. Scientists are aware of how these clusters shape and the ways in which they impact the surrounds the cosmic web and the findings, just those produced by the James Webb Telescope. The start of the Webb's ongoing mission, it will surely reveal more mysteries and provide fresh perspectives on the actual size of the cosmos in the future. This year's site will highlight a range of scientific objectives, from examining the extraterrestrial atmospheres in order to map the dark matter web's dissemination, will moreover collaborate with other observatories and telescopes like the future Nancy Grace Roman Space Telescope to provide a more thorough image of the cosmos as we gaze to the future. The James Webb Telescope is evidently will be crucial in determining our comprehension of the universe's findings. Will not only increase our understanding of the cosmos but also motivate next scientific generations. In conclusion, astronomers and explorers, the Space Telescope on the James Webb is rewriting how we see preventing the universe from exposing the staggering quantity of galaxies needed to unlock the dark matter web's secrets are evidence of human curiosity and resourcefulness. When we look into the depths of, we are reminded by space that the cosmos is much bigger, more intricate, and more lovely than we could have ever dreamed. The James Webb Space Telescope is adjusted, keeps bringing to light the beauties of demonstrating to us that the actual scale of the cosmos is just now starting to comprehend. The James Webb Space the Telescope, JWST, is more than simply a marvel of technology. Additionally, it represents humanity's continuing knowledge-seeking as we traverse this. The telescope is the new age of astronomy, allowing access to inquiries that have stargazers and scientists have long been perplexed. Similar to one of the most intriguing fields among studies made possible by JWST is the investigation of exoplanets. Atmospheres. Comprehension of these distant worlds' composition is vital in looking for indications of life. Besides recognizing water vapor, the Internet may identify several more gases, such as the carbon dioxide and methane levels, when discovered together, may suggest biological mechanisms akin to those on Earth. This comprehensive strategy gives a more thorough overview of the circumstances that may sustain life. The telescope has sophisticated spectrometers with light analysis capabilities. From far-off exoplanets as it moves by, navigate their environments by looking at. With this light, researchers may deduce the existence of certain compounds and gauge the probability that this will be habitable is very thrilling, as a large number of the network of exoplanets will see situated within the infamous Goldilocks zone areas around stars where the circumstances are ideal for liquid water to exist, in addition to having the capacity to see at wavelengths infrared, enables it to research orbiting exoplanets. M-dwarfs are colder, fainter stars, the most prevalent kind of stars in the cosmos, and several possible around them are planets that are livable. The information from JWST may show whether there are atmospheres on these worlds, and what their composition may be, paving the path for more research and potentially upcoming expeditions to these planets. In addition to its contributions to the exoplanet research, is also making advances in our knowledge of the galaxy. Establishment and development of the telescopes. Its unparalleled sensitivity allows it to examine galaxies during different phases of their evolution, from the first, quickly after the massive boom, to more developed galaxies nearer to us. These observations aid scientists throughout time assemble the intricate history of the cosmos, encompassing how galaxies, over billions of years, combine and change. Another fascinating field of study is the study of cosmic structures. Referred to as cosmic threads, these enormous threads of gas and dark matter that join groups of galaxies to create the foundation of the large-scale universe. Structure by the mapping of these filaments. JWST may provide information on how matter is and how galaxies interact, dispersed over the universe. Knowing these structures not only provides insight on how galaxies develop, but also provides hints on the nature of dark matter that continues to be among the most mysterious elements in the cosmos. In order to fulfill its mission, JWST will also explore the study of stellar areas that serve as nurseries for new stars born. Knowing the procedures that control the creation of stars is essential to our understanding of the universe's web. With its infrared capabilities, it can break through the thick gas clouds and dust that usually covers these places. From the perspective of these nurseries, researchers may collect information on how our sun's shape changes with time, and finally, additionally, the JWST observations expand outside our galaxy's borders. The telescope is ready to look into clusters of galaxies that were far away. After just a few 100 million years, these ancient clusters can withstand the Great Explosion, provide an indication of the state of the early cosmos, and assist researchers comprehend the formation of the earliest galaxies, and evolved by researching their attributes that allow astronomers to improve models on cosmic evolution and comprehend the physical mechanisms that created the James Webb Space, which molded our universe. Additionally, a telescope may examine the exoplanets' atmospheres in additional information that might provide additional details on their potential for using life. As an example, the investigation of seasonal variations in the air temperatures of these planets can have differences that can be a sign of biological activity, might result in new approaches for finding extraterrestrial life, as researchers will be able to search for patterns or irregularities in the atmosphere, information that is consistent with biological. Parallel JWST procedures are improving our comprehension of the enigmatic gravity wave phenomena. These space-time rippling anticipated by the general relativity hypothesis developed by Einstein provide a fresh perspective on cosmic happenings via arranging observation with gravitational wave detectors located on the ground. The Internet may provide further information that improves our comprehension of events such as neutron star formation and black hole mergers. Clashes. This collaboration between astronomy of gravitational waves and conventional methods of observation include a fascinating frontier in contemporary astrophysics. As the observatory collects further data, it will also be crucial function in enhancing our comprehension of researchers studying dark matter and dark energy. Think that the dark energy is believed to propel the cosmos. Accelerated expansion is composed of about 68% of the entire amount of energy in the universe by looking at far-off supernovas, and JWST galaxy clusters may be useful. Limit dark energy theories that provide fuller understanding of this mysterious. In brief, force is the James Webb Space. The telescope will change our comprehension of the cosmos in ways that we are only starting to understand. Its advanced infrared capabilities. News of observation opening up a fresh avenue. Investigation from the hunt for livable exoplanets for the investigation of cosmic systems and the dynamics of star creation. As we keep examining the information produced by JWST, we are not observing the stars alone, we are tearing apart the fundamental structure of the every discovery in the cosmos itself adds a component of the puzzle that offers a more deeper comprehension of our position in the universe.